Thank you everybody for joining us on this webinar. My name is Vikram and we are GL Communications. I am joined on this webinar by my colleagues Mike Yang, Sanjeev Jigajini, and also Sanjeev Kulkarni is also joining us. We can go ahead and get started. The title of this webinar is High Density Multi-Protocol Monitoring of Ethernet and IP Networks. This is a very popular solution of ours. Many of our customers inquire about our capabilities here when it comes to this stuff. So we'll dig in and go ahead and get started. I think many of you are already familiar with GL Communications, but if not, we are headquartered in Gaithersburg, Maryland, United States. We've been around for over 30 years. We do engineering consulting services, and we also manufacture test and measurement equipment for all different types of telecommunications networks. So whether it's analog, TDM, Ethernet, IP, SONET, wireless, 2G, 3G, 4G, 5G, land mobile radio, pretty much every type of telecommunication network out there, we have some sort of test and measurement capability for that network. We can analyze these networks, we can monitor them, we can visualize the traffic that's flowing across them, we can capture traffic, we can store the traffic long term. So basically we can do a lot when it comes to all these different types of telecommunications networks. Okay, so a lot of our customers ask about the ability to capture at high speeds. So basically capturing packet data at high speeds, whether you're at 1 gigabit per second, 10, 25, 40, or even 100 gigabits per second. These days the links are getting quite fast, and the demand is to be able to capture at these super high data rates without loss. So you see that here in the first bullet. Customers want to be able to capture traffic without losing packets, even at these very high speed data rates. And furthermore, you probably don't want to view all of the traffic, especially if it's coming in at 100 gig. You probably want to filter on a subset of that traffic. So maybe you want to filter on a particular source or destination IP address, a specific protocol, a specific port, and so forth. So customers want to be able to filter on the traffic that they want. They want to be able to comprehensively analyze this traffic. Our bread and butter is being able to analyze voice over IP and wireless IP traffic. We can do a lot. Actually, just recently we've released more capability that we'll talk about later in the PowerPoint. But staying on the subject of voice over IP calls, we can build call detail records for all of the calls. We can record the calls. We can analyze the calls for voice quality. We can store the calls long term. We can analyze all different types of aspects on the calls, including a variety of key performance indicators that we'll talk about later on. We can view all of the data from a nice centralized dashboard. That's this bullet down here. We'll show you what that dashboard looks like. When you're capturing at such high data rates and from many different locations, you want to be able to easily view the data from a GUI and be able to quickly get to the traffic that you're interested in and do the analysis that you want to do. So we have a very comfortable GUI for viewing this enormous amount of data that's coming in. Our solutions are portable. You can take them out to the field. We also can put them in data centers and server rooms and so on and so forth. So that's a big advantage that our solutions have. We have a variety of different form factors. And we can also play back the traffic. So once you record the traffic, you may want to also play back the traffic at a later time, maybe to test a certain application for performance certain network infrastructure or certain applications that are using the traffic. So we can do a whole host of different things when it comes to capturing high-speed traffic on Ethernet and IP links. HD stands for high density. High density meaning these high data rates that I'm referring to at up to 100 gig. We're going to talk about a lot of different things in today's webinar. We'll talk about the different types of configurations we have for our HD appliance. Then we're going to talk about the applications that run on our hardware, FastRecorder and PacketExtractor, to record high volumes of traffic. Then we'll dive into PacketScan for analyzing the traffic. Then we'll talk about the ability to deploy these probes that can monitor a high volume of simultaneous calls, more than 50,000 simultaneous calls we can monitor. And finally, we'll conclude with our web-based dashboard called NetSurveyorWeb. So we kind of put it all together. We start from the ground up. We talk about the physical hardware, and then how we do the recording, then the analysis, how we can really scale up to over 50,000 simultaneous calls, and then we conclude looking at our web-based dashboard, which brings it all together. Okay, so we have a lot of different configurations for tapping into high-speed Ethernet links. To make it simple, we basically group them into a low end, a medium end, and a high end. And what's the difference? Well, the difference is in terms of the data rate, as well as the RAM and the storage capability. So you can imagine that as you go to higher speeds, 25 gig, 40 gig, 100 gig, you're going to fill up your RAM pretty quickly, and you're going to fill up your SSD very quickly as well. So you will need a lot of storage and RAM capability as you move to higher data rates. So this table kind of summarizes our low end, medium end, and high end. A couple other important points I want to mention. If you look at these systems, they're very convenient portable lunchbox PCs. So these are, you can take these out into the field. You can deploy them at a variety of locations. You can put them, take them with you in the car, put them in a backpack, put them in a Pelican case. You can do a lot with these lunchbox PCs. They're very, very portable. And again, they pack a lot of horsepower. So, we can put whatever type of specialized network interface card that you're interested in, we can put it in these lunchbox PCs. We can put combinations of them as well. So, whether you want a 4x1/10 or a 2x1/10, or 8x10, 2x40, all these different configurations are possible depending on what type of high-speed Ethernet network you are looking to capture across. Okay, so that's what the solution looks like. The next thing we need to discuss is how you want to physically tap into the network. So the most standard way to do this is to connect the PacketScan HD appliance to a monitor port on a switch. So, you may have a high-speed switch, and these switches will come with monitor ports where it will copy the traffic from any given switch port to another switch port called a monitor port. And then you can see all of the traffic coming out of the monitor ports by plugging in these special fiber optic cables that go straight into the NIC on our PacketScan HD hardware. So I should mention this lunchbox PC, the whole solution is called PacketScan HD. So this is how you tap into your networks, you would usually want to do it by going through the monitor ports on a switch. You can also use a network tap. And network tap, you would plug it in line on the network, and it will copy the traffic as it passes through and send it out a monitor port and then into your PacketScan HD. So this is how you physically tap into the network to grab all the traffic that's going through. Again, these cables here are called breakout cables. So it can basically aggregate all of the different traffic from multiple monitor ports and feed them into one or two higher speed network interface card ports. And again, we can put multiple network interface cards on the PacketScan HD. So here we're just showing like a 2x40/100 NIC, but you can put multiple cards. In fact, right above it, we have another network interface card with 4 ports. So you can do a lot of analysis through all of these different ports. Then the question is, okay, from the software perspective, you can easily configure, am I looking at 1 gig links? Am I looking at 10 gig links? Am I looking at 25 gig, 100 gig, and so on and so forth? It's very simple once you fire up the appliance to just select from a drop-down menu what data rates you're analyzing and what type of configuration you want the network interface card to be in. So it's very easy to configure it all from a graphical user interface. Just click from a drop-down menu and you can easily configure everything. So I've covered basically the physical hardware that makes up PacketScan HD. I've covered how to hook it into the network to grab the traffic. Now we're going to start digging into the different types of applications you can do with our solution. And it starts with these 2 applications, FastRecorder and PacketExtractor. And at this point, I'll turn it over to Mike, and Mike will talk about these applications.
Thank you, Vikram. Let's go to the next slide. Okay, so the first application that we're going to discuss is the FastRecorder and PacketExtractor. So this is actually a single application. There's 2 sides to it. One is to record the data, and the other one is to extract it, sort of as the name suggests. So the FastRecorder, it's basically a wireless capturing module that allows for continuous, lossless, error-free capture at a rate of up to 80 gigabits per second. So we provide nanosecond timestamping, hardware filtering, packet slicing, and IPv4 and IPv6. And I'll talk a little bit more about each of these features as we go through the slides here. Let's go to the next slide. Okay, so this is what the GUI looks like. As you can see on top, there's 2 tabs, one for Packet Recorder and the other one is for Packet Extractor. So this is a very simple GUI that allows the user to configure the parameters, configurations that they need to start a capture. So you'll see in the FastRecorder configuration tab, based on the card type that's installed on the system or that's available to you, you can select the number of different ports that are available. Each port has the rate that's defined in the adapter title there. So in this case, it's a 4x1/10 gig interface. So each one of these ports that you see represents a either a 1 gig connection or a 10 gig connection. So you can select the ports that you want to capture on, give it a recorder name, the packet slicing option. So basically that allows you to sort of slice the packet or selectively discard parts of a packet so that you're only capturing a limited amount of packets. And why would you want to do that? So let's say you have lots of data coming in at maybe 100 gig per second. And you're not interested in all of the packets for all the data that's available in that packet, right? So for example, the payload of the packet you might not be interested in. So to limit the size of a capture, you can do a packet slicing. So let's say you just want to capture the first 50 or 60 bytes of a packet, just so you have information like the packet header. So with this option, we give you the ability to selectively capture a fixed size packet. And then in the drive section, you'll see that there's 4 drives listed here. So these are NVMe drives. And the way we record is we actually write to all 4 of these drives simultaneously. And these are sort of written in a kind of sort of proprietary format. And that's why we have a packet extractor application that extracts the recorded packets. So as the FastRecorder writes, it'll write to all 4 drives simultaneously. The drive space depends on the size of each NVMe disk. For the portable version, we can use up to 8 NVMe drives. That gives you up to 120 terabyte of storage. It's also possible to configure this in a rack mount, which gives you much, even higher density. So you can go way beyond the 8 drive limitation. And then for the record option, you can define a size of your recording. So in this example, it's showing 100 gigabytes as the record size. You can stop after the 100 gigabytes is captured, or you can select the keep latest, which is basically a continuous capture, and it'll keep the latest and number of gigabytes that's defined in that box. Okay, let's go to the next slide. So now we're talking about the hardware filter. So there's really 3 options here. You don't want to do a hardware filter. You want to apply an advanced filter, and then there's a predefined option that we have here. Let's go to the next slide. So this is the advanced hardware filter. So you'll see here there's a bunch of protocols that's listed in the sort of the middle box there. So you can filter based on things like the frame length, the MAC address, VLAN, including the VLAN ID, the tag protocol ID. You can filter on, of course, the IP address, including IPv4, IPv6. You can filter on the protocol type. We have a few listed in here: TCP, UDP, SCTP, SIP, RTP, as well as GTP. Now for GTP, we can filter on things like the user plane or the control plane. There's a drop-down in there that lets you choose between the two. And then even for the RTP, there's an option to filter out RTP traffic that's been encapsulated in GTP. So this is sort of useful for capturing in the wireless space, so like 3G, 4G, 5G protocols, where you want to capture calls that's happening in the 4G or 5G network, where those calls are all sort of encapsulated in GTP traffic. And for each of the filters, there's also conditions for doing and or, so you can define multiple filters, apply a and or condition, which gives you the flexibility to create all kinds of hardware filters. Let's go to the next slide, which gives an example of configuring the IP address. So you'll see here, you can click on the add button to the right, which gives you this IP address window, and then we give you some examples of how you can specify the IP address in this list. So you can be a single IP address, multiple IP addresses, or you can specify a range of IP addresses within the same subnet, or you can have wildcards even for capturing the entire subnet. So this is true for both IPv4 and IPv6. Okay, let's go to the next slide. So now moving on to a predefined type of hardware filters. So these are custom definable filters. We have a couple of basic ones that sort of used quite frequently, I would say. So you can define an IP address pair within this GUI. So if you just want to monitor communication between two IP addresses, you can define the IP address pair, and then in the protocol section, you can define what kind of protocol you want to monitor within this pair. So things like UDP, TCP, GTP traffic, and so on. And then for the IP address pair, this also includes GTP IPs, GTP IP addresses. You can do a inner IP address and an outer IP address. Both you can select the pair of inner and outer IP addresses. Let's go to the next slide. Okay, so with the configuration and the hardware filter defined, you can start the recorder. And while the recorder is running, we have a statistics tab, which shows you all the information that's of all the frames that are being captured. So you can see the total number of frames captured. If you have a hardware filter turned on, how many frames match that hardware filter. You can look at the number of bytes recorded, the capture rate, how long the recorder has been running, and yeah. Let's go to the next slide. Okay, so in addition, we also give you a per port and aggregated statistics. So here for each of the port, you have individual stats for the port. So again, things like how many frames are captured, how many frames match the filter, and then going even deeper, you'll see how many frames fall into certain byte range, right? For example, how many frames fall into the range of 128 to 255 byte length. And if there are any errors that were captured, CRC or align errors, those are all displayed here. You can also monitor the port link status, as well as the temperature of the SFP that's being used. Let's go to the next slide. Okay, so once you have everything recorded and you've stopped the capture, now we can use the PacketExtractor application to actually extract your recording. So you can select the recording that you have done through the FastRecorder by clicking that select recording button. That's gonna bring you a list of recordings available. You can select the recording. It'll tell you when the recording started, when it ended, the size of that record, and then in the extraction sort of criteria there, you can actually define how much of the recording you want to extract. You can do this based on a duration. So from the start time that you put in that box there. So let's say you start from the beginning of the recording, you can define how, based on the duration, how much of the recording you want to extract. You can extract based on a packet count, and you can extract based on size. You can also extract based on a port filter. So let's say you've captured on ports 0, 1, 2, and 3, and you just want to extract on ports 1 or just 1 or 3. So things you can define in that port filter there. There's also another layer, a filtering layer that you can apply here after, or that you can apply during the extraction. So let's say you captured everything without applying a hardware filter. So you have all of this data that's being recorded. Now, when you go and extract it, you can hit that filter configuration button, and that allows you to filter out data again based on things like IP address or protocol type, so that you're not extracting a huge amount of data. So you're just extracting the sort of the packets of interest to you. Okay, and then in the destination file name, we can extract to an HDL, which is our proprietary format that we use for PacketScan, or we can extract it to a PCAP format, where you can look at the file in something like Wireshark. You can extract to one large file, or you can split it into multiple files. There's also an option to compress the extracted file, so that the file size is much smaller after it's been extracted. Again, you can apply packet slicing during the extraction, so that you're just looking at a fixed length for a specific packet. Okay, I think that covers the FastRecorder and PacketExtractor. I'm going to turn it back to Vikram, who's going to discuss the PacketScan HD.
Okay, thank you, Mike. So now we've covered how to record all of the traffic that you're grabbing from the network. And now the next step is to analyze all of the traffic that's coming in. So we have a software program called PacketScan, and it runs on our hardware appliance called PacketScan HD. So let's talk a little bit about what this protocol analyzer can do for you. Okay. So PacketScan is very versatile. It can cover a lot of different protocols. You can see some of the listings right here. So wireless networks, it can decode wireless protocols like LTE, IMS, UMTS, and so forth. It can also do voice over IP type networks, so it can decode SIP and RTP, SIP-I and Skinny and all these other different types of protocols. And it can do conventional protocols as legacy protocols as well, so like SIGTRAN, SS7, ISDN, and so forth. So so PacketScan can do a lot of analysis on a lot of different protocols. And all you really need to do is make sure that the hardware appliance can physically connect in through a wired connection on a mirror port on a switch. So we can grab all of that traffic. So this is a couple of the different types of examples where you can monitor across. Like I said, here's a table that talks more about the supported protocols and the supported codecs as well for the voice calls. This list is not all inclusive. We have even more protocols and more codecs that we list on our website. But these are some of the most common ones that customers ask for. So as you can see, we support a lot of different protocols and codecs. Okay, so Mike talked a lot about these hardware filters, so I don't need to talk too much about it, but the key here is that because we can filter at the hardware level, it's wire speed. We won't miss packets as we're applying this filtering logic. And so even if you're capturing at super high speeds, when we apply this hardware filter, you can rest assured that you'll get only the traffic you want and you won't miss any packets. So that's the advantage of the hardware filter. Then through the software, we can define more filters like this capture filter and a view filter. So these are just to help you in terms of viewing the traffic that you're interested in, so you don't get inundated by millions of packets passing through every second. So here is a few snapshots of what the PacketScan software looks like. One of the applications in PacketScan is called the Packet Data Analyzer, and it will basically take all of the packets and group them into calls. So each one of these rows is a distinct phone call. In this case, we're looking at VoIP calls from one IP address to another. You can see things like the start time, the duration. For every single call, you can click on it and you can see the ladder diagram, so you can see the call setup and teardown. You can get a whole host of different types of statistics, how many packets were involved in the call, what was the encoding. even, I apologize for the font being a little small here, but you can even get the mean opinion score. I have a better graph of that later on. So we can analyze the voice quality of the call. So basically, it can take thousands and thousands of packets, millions of packets, group them intelligently into calls, and then present the calls line by line so that you can see each call and zoom in on that particular call. Okay, now another thing you can do is you can define a trigger based on certain criteria in the call. So maybe you're interested in a certain calling number or a certain called number, or maybe you're interested in, whenever there's a failed call or a passed call, or maybe you're interested in, whether it's a voice call, a fax call, a certain call duration, and so on and so forth. Basically, there's a lot of different things you could be interested in the actual call. So you can define a little trigger here, and whenever that trigger fires, you could then define follow-on actions. So you can save the call. You can say, okay, whenever I see a call from a specific calling number, I want to save that call, or I want to export the call detail record, or I want to record the audio to a file. If it's a fax call, I want to extract the fax image. And so this is really nice because, if you're monitoring tens of thousands of calls, you want to be able to set up these automatic triggers and actions. You can also send an email based on a specific call that came through, so you can get an email alert. There's also a little dashboard where you can see the alert on the dashboard. So there's a lot of different ways that you can be alerted when something that you're specifically interested in occurs. Like I said before, we can calculate voice quality on the call, so we can in both directions independently. So the green line here is one direction of the call, and it's basically getting a perfect mean opinion score throughout the whole duration of the call. Whereas the other side of the call, the voice quality varies throughout the duration of the call and is pretty degraded as compared to the other side. So we can do that type of analysis. We can determine the mean opinion score for each side of the call. You can see it, you can graph it, you can set up a trigger on it, you can alert yourself on it, and so forth. Okay, so a lot of customers are interested in monitoring phone calls, but we can also do TCP analysis as well. So most the phone calls are usually going over UDP, but data is usually being transferred over TCP. So file transfers and HTTP traffic and FTP, SSH, and all this other types of traffic is happening over TCP. So we do have, just recently we've released a lot more capability in terms of our TCP analysis. I won't spend too much time on it right here, but we do have a lot of TCP capability as well. So here's one more slide that shows some of our TCP capability. Let's move on. And now what I'll do is I'll hand it over to Sanjeev Jigajini, and he'll kind of talk about the ability to really scale up and do lossless capture over tens of thousands of phone calls, and then putting it all together in our NetSurveyorWeb platform for more easy viewing. So Sanjeev, you can go ahead and get started.
Yeah, thank you, Vikram. As Vikram mentioned, here we'll be continuing on the extended version of this probe, which can be used to capture the high volume traffic without loss and decode these all traffic to build the call detail records and other important statistics. So here basically we have will be having two models, like one which is going to connect, listen to this traffic and capture them, and we can perform even this different level of hardware filtering. Hardware filtering can be done, which we can do it on different protocol layers. Like as Mike mentioned, we can have like IP pairs for IPv4 or IPv6 traffic, or we can do for the specific like inner like GTP traffic, which is all these SIP calls, which is encapsulated within this GTP traffic. So we can apply filters for those traffic, or we can even can capture them without any filters. And as Mike mentioned, we have this fast recorder model. So all these traffic which is being coming to this SmartNIC will be recorded to like all the these NVMe disks, which is a very faster disk. We can configure this as per the requirement. So we can rack up these NVMe disks. So the fast recorder will be capturing all the traffic at the higher rate without losing any of the traffic. It is like lossless capture. So once we have all these traffic into this disk, we have a module which will be looking into this captures and decode all the traffic to build the CDRs. So like it will associate all the packets into the call detail records, and even it will bind the voice which is associated to these calls. It will generate these CDRs. So along with this, we can even provide input, like if the user wants to mark any provide any input, like if he wants interested in analyzing or looking into any specific calling or call number. So in that case, user can provide these configure the whitelist, so that we can take a action on those numbers when we receive the calls with that calling or call party. Along with this whitelist, a user can even set some threshold. Say for example, while monitoring these voice calls, we want to know, like understand the reason for the degradation in the call, like voice quality. Since it is IP network, we may experience the degradation in the voice quality. So in order to dig into that particular call and troubleshoot that, we can set the thresholds. Like if certain the voice quality is going below like certain criteria, then we can trigger that and take action. Like we can record that entire call, or we can record even the voice out of it. So all these analyzed traffic can be returned to the CSVs, which are then dumped to the NetSurveyorWeb system. This NetSurveyor system is contains of database and a web browser server. So all these data will be available in the database, and we have a web server application, and user can use a web client to connect this and access all the data and perform historical analysis, and even download the reports. So this high density like IP probe can analyze up to 50K plus simultaneous calls. And as I mentioned, we can perform different configurations in our while analyzing. We can configure them to export the CDRs and associated frame details into the CSV format. These CSV files will be forwarded to the database system, where all these CDRs will be dumped to the database for further analysis using our NetSurveyorWeb client. So along with the CDRs, we can even configure to record that particular call, or even the voice of that call. So we can even do the selected recording, or trace recording the voice, or the trace record. So we can do by configuring those as I mentioned, whitelist. So user can configure these VIP numbers or whitelist for which we want to record this traffic or take the entire call trace. So in order to specify this, we can user can specify, we support wildcards, so that user can specify the entire like exact calling number, or he can specify even the pattern. For example, you could see here, user can specify like starting with 30 in 301, then rest numbers can be anything. So he can say 301 star, so that all the calls with call or calling numbers starting with 301 will be marked as a VIP or whitelisted calls, and then proper action is taken on either trace record or voice record. Same way, we can specify wildcard star or even question mark for a single placeholder. So with this configuration, we can identify the particular called or calling numbers of interest. As I mentioned here, we can even record the voice calls, all the white calls, or as we mentioned, we can do whitelisted calls. And also, in case among this, if we are interested in only the calls which have degraded, we can do the recording on these degraded calls. So this IP probe here along it works with this fast recorder, which will be capturing at the higher rate, and this packet data analyzer will be analyzing all these recorded traffic simultaneously. And then in this module, it provides important statistics like total number of calls it has processed so far, and what is the number of active calls currently it is processing, and how many calls are like completed, and how many frames we have processed. Apart from this, even it will provide per protocol statistics. You could see here like SIP, how many SIP messages I have processed, and how many SIP calls are being currently running, and even the message statistics. And with respect to RTP, we do provide like how many active RTP sessions are being currently analyzed, and how many of them are completed. And also we provide these important voice quality metrics, MOS, and also like important missing packets and out of sequence duplicates, discarded packets. Or overall statistics for all these sessions. Along with that, we provide some additional statistics like how many of these calls are whitelisted calls, and out of which how many currently are being recorded, and what is the current count we are recording, and total number of calls which we have recorded, which has triggered either the call trace, whitelist, or the degradation criteria. So when all these data, which is analyzed by the IP probe, we send to the database, then user can access those data using our NetSurveyorWeb, very user-friendly web dashboard to access and analyze the traffic. So this NetSurveyorWeb, it can, along with this IP probe, it can even work with all our other TDM analyzers or wireless analyzers, so which can be hooked up into the specific network, and they analyze these all the traffic, and they can send these analyzed CDRs and the recorded voice data to the centralized database server. So once we have this data available in the database, multiple users can log into this our server using a web browser, simple web browser, and they can perform the analysis on traffic of like a particular call analysis, or they can do look into the graphical statistics and perform various analysis into those calls. So it works with multiple probes, as I mentioned, and we can do real-time and historical analysis also. Like we can look into the particular date time in order to apply those date time filters, and look into that particular period, how the calls have been there in the network. And we even provide a rich like graphical and tabular formats, so reports in tabular formats, so that it will be easy to understand the network characteristics. And we have option to even download the trace and ability to play back the voice calls which are recorded at the time of analysis in the probe system. So this is the main dashboard when user logins to our NetSurveyorWeb application. So it provides various options to dig into that particular calls based on this. You can see the time filters. We have like apply the filters like quick filters like today, yesterday, and last 7 days, or last 30 days, or even we can specify the time range between which we can which want to look into those traffic. Along with that, we can even quickly search on these parameters. For example, if I would like to search all the calls which are being placed by using a particular caller, or all the calls which has the voice quality is good, and all the calls which have failed due to some other reasons. So we can do a quick search based on the caller, callee, and all these CDR parameters. Along with this, we can do this a quick view wherein, as I mentioned, we can mark them as whitelist, or we can record them with the trace files or the voice files. So we can have a quick view here on the left side, so that on clicking this will directly going into those set of CDRs, and one who is interested in those categories, they can directly use this option to dig into that set of calls. So you have option, you want need to do the detailed analysis of the selected calls. So once we click on the detailed analysis, select a call, and when we click on detailed analysis, so we'll be getting all the information in one page. Like we'll be able to see all these CDR parameters like calling, call number, start time, duration, uh, if it is any failed call, and what is the failure cause for that, and if it has any traffic, it will give all these voice quality statistics and other RTP performance metrics. So along with that, we'll be able to see the graphical representation of the message flows which are exchanged between this caller and call party. So this helps in understanding how the message has been exchanged between the endpoints, and what time it has been exchanged. And if you want to look into the particular field within that message, we can click select that message, and you will be able to see that entire decode detail of that selected message. Along with that, we even provide the important event summaries, like when the call has been started, and when the call has been answered. So we can see these, even the important events happen during the call. So as I mentioned, we can even do the voice recording. So once we have this calls which have been recorded at the pro system, then user can click on this play button, wherein he can even listen to the voice which is recorded, or even he has option to download the file into the WAV file format, which can be played back using any of these players. So within this, even we can play the particular session. If it has bidirectional traffic, we can, if you want to listen into the particular direction, we can do a left session, right session, or even the merged traffic. So in the next slide, as I mentioned, we can even record or the entire trace, so which can be used for further analysis, or which can be shared to any of the further team for doing any troubleshooting. So this is a very important feature here. When we have these calls available in this database, if you want to download the particular call, so that all the frames associated that call can be viewed using either our GL proprietary PacketScan offline analysis, or we can even download them to a PCAP or PCAP-NG file format. So with this, if any of the calls which is identified as to be analyzed further or troubleshooted, so such traces can be downloaded and forwarded to other teams or further analysis. So in the next slide, so we do provide these very important reports, which we call like key performance indicators. So when we are analyzing these networks, so looking into the overall network uh, picture is very important. So in order to have that, we provide all these key performance indicators. Like if you could see these reports, we have like how many calls have been generated in. We'll be showing them in terms of reports wherein it will show all calls, out of which how many calls are failed or how many calls are actually answered, and what is the voice quality. If it has traffic, then what is the quality of those calls, whether it is a good, poor, or fair, or if there is no like traffic on that, and then we can say that's quality not available. So we can see all these together in a one view, so that we can just understand what is happening on that network at that given point of time. So we can define even our own custom KPIs, or currently we'll be providing with the standard defined KPIs like whitelisted or non-whitelisted, which will differentiate between the configured whitelisted calls and non-whitelisted calls, and also voice recorded and non-voice recorded. And if we have recorded the trace, and it will show how many calls have been recorded with the trace files and how many which have not recorded with the trace files. So these KPIs will help you in understanding the entire network behavior. In the next slide, we see some more KPIs like what is the call success ratio, and how the calls are distributed across the time period. Like you can see call durations which are greater than 30 seconds, 1 minute, 30 minutes, or more than 1 hour. Or if we have any issues while connecting the calls, then we can use this performance metrics like session request delay, disconnect delay, which will help us in understanding that if we have any issues while connecting the calls. So again, we'll be having we can have many such KPIs as all the data is available. So user can come up with their own KPIs in order to understand the or get the reports. So all these reports, we can even export them to a PDF or into and send those reports through a mail, configured mail addresses. So as I mentioned, even once we have these reports, we have option to display them in different tabular formats like bar chart, pie chart, dotted chart, all these things. And once we have these calls, you can see this the calls which are how many calls are good, fair, and poor. So from these like reports, if we want to go into those calls and look into those CDRs, then we can use these legend. Click on those legends like good, fair, or poor. Those will be navigating to those exactly. For example, if I click here on poor, then it will navigate to us like where all I can see the CDRs, all 16 CDRs, and I can select any one of them and see the exact reason for the poor quality of that call. Similarly, we can use this for looking into that specific failure call reasons, why the calls have been failed and what is the reason, whether it is due to like user or the network error or any other errors, so that we can quickly go into those calls and look into the details. And in the next slide, as I mentioned, all these reports we can even export to the PDF or HTML, uh, or even all these reports PDF or HTML, we can send them to a specified mail addresses. We have an option to configure the mail addresses so that all these reports we can exchange with different users or other team, so that they can look into that directly into the reports in order to understand that behavior of the network. And we have even one more important features, like as and when we are analyzing this traffic and it comes to the NetSurveyorWeb, we want to automatically alert the users, so that if there are any like so many failed calls happening in the network, or we are seeing a lot of poor quality calls in the network, then we can such configure such alerts, so that once that such trigger is happened, and it can be alerted using any of our types, like we can send a email. As I mentioned, all these reports will be sent as an email, or we can even log to a particular file which can be further looked into or analyzed. Or also we can set some of the audible or visual alarms, so that the system can provide this alerts when there is something happening in this network. So this we have like all these options in order to analyze this traffic. So with this, we'll be concluding all this high density IP probe and NetSurveyorWeb monitoring solution.
Okay, thank you, Sanjeev. Thank you, Mike. So thank you, everybody, for attending.